Hello everyone. Today we are going to learn on what progress and advancement is made in the microprocessor since the year 2006 in the form of multi-core technology. In other words, we are going to study various characteristics of the microprocessors and compare them on the basis of these characteristics since 2006. In one of the earlier session, we have studied the various versions of the microprocessors from 1980 to 2006. The objective of the today's session is to understand the multi-core technology introduced by Intel Corporation in the microprocessors in 2006 and further advancement in this technology till 2013. So, let us start the session. The Intel designers, while designing advanced versions, observed that increasing the clock rate beyond 2.5 gigahertz or more not only consumed more power, but also dissipated more heat. The increased heat dissipation required sophisticated technology for cooling and maintaining temperature within limits. To eliminate this problem and still improve the performance of the CPU, Intel announced multi-core technology in 2006. The multiple core implies that the single chip contains more than one central processing unit. One central processing unit is termed as one core. A multi-core processor is a single chip component with two or more independent central processing units, also called cores as explained earlier. The cores are the units that read and execute program instructions. The instructions are ordinary CPU instructions such as add, subtract, multiply, divide or move data from one memory location to another and branch. But the multiple cores can run multiple instructions at the same time, increasing overall speed for the programs amenable to parallel computing. The manufacturers typically integrate the cores onto a single integrated circuit die known as the chip multiprocessor or CMP. The experimental results proved that a processor designed with multiple core technology with lower clock rates not only dissipated less heat, but performed better than single core having higher clock rates. The processors were originally developed with only one core, but later on with addition of multiple cores, like various terminologies are there to describe the multi-core technology. A dual core processor has two cores. A quad core processor contains 4 cores. A 6 core processor contains 6 cores. An 8 core processor contains 8 cores on the same chip. Similarly, 10, 12 and up to 24 or 48 cores are now available on a single chip. A multi-core processor implements multiprocessing in a single physical package. The designers may couple cores in a multi-core device either using tightly coupled fashion or loosely coupled fashion. For example, if the cores share a common cache, then it is called tightly coupled, or if the cores implement message passing for communication between each other, then they are called loosely coupled cores. That means the loosely coupled or tightly coupled depends upon the inter-core communication methods. The common network topology to interconnect cores include bus, ring, two-dimensional mesh and crossbar. The homogeneous multi-core systems include only identical cores, whereas the heterogeneous multi-core system have cores that are not identical. Just as with single processor systems, the cores in multi-core systems may implement architectures such as superscalar, very long instruction word in short called VLIW, vector processing, SIMD, single instruction multiple data or multi-threading. The terms multi-core and dual core most commonly refer to some sort of central processing unit, system on chip or refer to multi-core microprocessors that are manufactured on the same integrated circuit die. The separate microprocessor dies in the same package are generally referred to by another name, such as multi-chip module. The terms multi-core and dual-core for CPUs manufactured on the same integrated circuit are generally used. In contrast to multi-core system, the term multi-CPU refers to multiple physically separated processing units, which often contain special circuitry to facilitate communication between each other. The terms many-core and massively multi-core are sometimes used to describe multi-core architecture with an especially high number of cores, maybe up to hundreds. The improvement in the performance gained by the use of multi-core processor depends very much on the software algorithms used and their implementation. In particular, the possible gains are limited by the fraction of the software that can be run in the parallel simultaneously on multiple cores. This effect is described by Amdahl's law. In best case, the application programs may realize speed up factors near the number of cores. That means, if you have 2 cores, you can realize a performance of a factor of 2. If you have 4 cores, theoretically you can realize a performance factor improvement of 4. But if the problem is split up enough to fit within each core's cache, avoiding the use of much slower main memory, then in those applications sometimes you can achieve even the performance improvement of the factor of even more than 2 if 2 cores are used, or even more than 4 if 4 cores are used. In most applications, the speed up and maximum utilization of all the cores is achieved only when significant effort is invested in refactoring the whole program, and the program is divided into sub problems to distribute equally among multiple cores. The sub problems and the division of the problem should be done in such a manner that the least data dependency exists between sub problems. The parallelization of the software is a significant ongoing topic of the research. The next we start with the business motives behind development of the dual core or the multi-core technology or multi-core architectures. For decades, it was possible to improve the performance of the CPU by shrinking the area of the integrated circuit, which drove down the cost per device on the integrated circuit. Alternatively, for the same circuit area, more transistors could be utilized in the design, which increased the functionality. Clock rates also increased by the orders of the magnitude in the decades of the late 20th century, from several megahertz in the 1980s to several gigahertz in the early 2000s. Also, the computer manufacturers earlier implemented symmetric multiprocessing designs using different CPUs connected through the network topology for communication. The issues regarding implementing multi-core processor architecture and supporting it with the software are well known since last 2 decades, because already parallel computers are designed using since last 20 years. So, the technology is well known. Only thing required was to fabricate these multiple CPUs now onto a single chip, which was done using multi-core technology. Additionally, utilizing a proven processing core design without architectural changes reduces design risk significantly. In other words, we are not designing a new powerful processor with latest technology. Rather, the performance is improved by interconnecting more number of well established processor designs on a single chip. Secondly, for general purpose processors, much of the motivation for multi-core processor comes from the fact that increasing the clock rate dissipates more heat and consumes more power. Therefore, the alternative is to have multiple cores with lower clock rates on the same chip. As the rate of the clock speed improvement slowed, the increased use of parallel computing in the form of multi-core processors has been pursued to improve the overall processing performance. The multiple cores were used on the same CPU chips in order to continue delivering regular performance improvement for general purpose processors, and therefore, manufacturers such as Intel and AMD have turned to multi-core designs for higher performance in the applications and systems. The composition and balance of cores in the multi-core architecture show significant variation across various designs depending upon the needs of the applications. Some architectures use one core design repeated consistently and therefore are called homogeneous multi-core technology, while others use a mixture of different cores, each optimized for a different heterogeneous role. The heterogeneous role also refers to a system where one of the core works as central processing unit and other cores serve the peripheral devices with built-in device driver capability on the chip. Intel has produced a 48 core processor for research in cloud computing. Each core has an x86 architecture loaded with Linux operating system. Next, we discuss the advantages of multi-core technology. The first advantage of multi-core technology is that the proximity of multiple CPU cores on the same die allows the cache sharing to operate at a much higher clock rate than is possible if the signals have to travel off the chip across the chip from one chip to another. The combining equivalent CPUs on a single die significantly improves the performance of the cache operations. This means the signals between different CPUs travel shorter distances and therefore, those signals degrade less. These high quality signals allow more data to be sent in a given time period, since the individual signals can be shorter and do not need to be repeated as often. The next advantage of multi-core technology is that physically the multi-core CPU designs require much less printed circuit board area than do multi-chip SMP designs. Also, a dual core processor consumes slightly less power than two coupled single core processors because of the decreased power required to drive signals external to the chip. Also, the cores share some circuitry like L2 cache, and the interface to the front side bus FSB is another reason for lower power consumption. Multi-core chips also deliver higher performance at lower energy. This energy efficient feature makes it ideal for use in mobile or other embedded devices that operate on batteries. A mobile device contains a chip designed to perform various complex communication and computation tasks required for signal processing and various other office applications. The different cores are dedicated and fine-tuned to perform the above tasks. Since each and every core in multi-core is generally more energy efficient, the chip becomes more efficient than having a single large monolithic core. This allows higher performance with less energy. So, what we have discussed are the advantages of multi-core technology. Next, we discuss the disadvantages of the multi-core technology. One disadvantage of multi-core technology is that changes in the operating system as well as application programs are required to fully exploit the performance of multi-core technology. Next, the raw processing power of the two cores does not ideally double the performance. It has been claimed that if a program running on a single core excessively use memory bandwidth, then going to dual core might give 30 to 70% improvement. If the application does not require memory all the time and memory reference is not a bottleneck, then a 90% improvement can be expected. Another disadvantage of the multi-core technology is its impact on the software design. A single application program can benefit from multi-core technology only if the application program is designed in a manner that simultaneously perform multiple tasks in parallel. Each such task runs under a program control called thread. The program is designed to concurrently execute multiple threads at a time. The programming truly multi-threaded code often requires complex coordination of the threads and can easily introduce subtle and difficult to find bugs due to interweaving of the processing on data shared between threads. Consequently, such code is more difficult to debug than single threaded code when it breaks. There has been a perceived lack of motivation for writing consumer level threaded applications because of the relative rarity of the consumer level demand for maximum use of computer hardware. Also, serial tasks like decoding the entropy encoding algorithms used in video codecs are impossible to parallelize because each result generated is used to help create the next result of the entropy decoding algorithm. The general trend in the microprocessor development has moved from dual, tri, quad, hexa, octa core chips to ones with tens or even hundreds of the cores. In addition, multi-core chips mixed with simultaneous multithreading, memory on chip and special purpose heterogeneous cores promise further performance and efficiency gains, especially in processing multimedia, face recognition and networking applications. There is also a trend of improving energy efficiency by focusing on performance per watt with advanced fine grain or ultra fine grain power management and dynamic voltage and frequency scaling. Next, we discuss the various applications where this multi-core technology could be useful or has found lot of utility so far. The multi-core processors are widely used across many application domains including general purpose systems, embedded systems, networking or digital signal processing and graphics. The multi-core technology is found to be useful for performance requirements of telecommunication domain for parallel data path packet processing. The processors designed using multi-core technology are replacing the traditional network processors. For the system developer, the key challenge is how to exploit all the cores in these devices to achieve maximum networking performance at the system level. On the other hand, on the server side, multi-core processors are ideal because they allow many users to connect to the site simultaneously and have independent threads of execution. Therefore, multi-core technology has found acceptance in web, application and database servers and have demonstrated dramatic improvement in the overall throughput. The term throughput is defined as the capability of the server to process the number of tasks in a given time. So, in short, what we have studied is the tremendous growth in very large scale integration technology called VLSI. The advancement in the technology has made possible the presence of multiple cores on a single chip, replacing the traditional multi-CPU machines. We have studied the business motives behind moving to multi-core technology. Also, the advantages, disadvantages and challenges of multi-core technology were explained. The increase in the speed because of the multi-core technology, the microprocessor can finish the complex task in less time. The graphics capability and the performance of the processors for scientific applications has dramatically increased because of the multi-core technology. The end result is that the user finds working on the computer system or accessing the internet faster as compared to the computer system based on the earlier versions of the microprocessor systems. The multi-core technology has reduced the power requirements of the processor, resulting in energy efficiency. However, the challenge is to exploit the full potential of multiple cores by making changes in the application software as well as the changes in the operating system design. It is difficult for the programmers to design, develop and maintain application programs executing concurrent tasks to run simultaneously on the multiple cores. Thank you.